Hey guys, so this is the question from 2011, and so I'm going to run through the code with you. And so we're going to start from the top of the assembly code all the way to the bottom. Okay, so the question is asking, what are the exact addresses and contents for the topmost 7 bytes on the stack after the execution of the following assembly code? Okay, so the first thing we note is origin $3000. So $3000 for origin actually corresponds to the instruction length. Okay, so we start from 3000, and every single instruction that we execute, we add in the bytes. Okay, so when we do the first one, we're adding 3 to 3000, and so far and so forth. Okay, and so for the so that's for the first one. Okay. For the second one, for the second line we do load load S, which is the stack pointer with the memory location of $4000. So that's the second thing we do. Okay, so we go all the way on the bottom because it's a last in first out system. The bottom here will always be $4000 or whatever you set your stack pointer to. Okay, and when it's a last in first out system like this, things go in from the top to the bottom. Okay, so for the first one, the stack contents is always reserved. It could be XX or ... meaning that we don't know what it is, but it's always reserved. We won't be putting anything in there. Okay, so the third line is clear A. Okay, so clearing A, and that means that A in accumulator A, it's actually $00, which is 0. It's cleared. Excuse me. So the fourth line we have is load accumulator B with $57. Okay, and then we have load register X with $74. So an interesting thing I want you guys to know is that in the HCS12 we have the following registers. Okay, and so for A and B, these are both accumulators, but D is actually the combination of A and B. Okay, so that explains why that D is a 2-byte accumulator or a 16-bit accumulator. Okay, and so D is also this A and B combined. Okay, keep that in mind. Similarly, X is a 16-bit or 2-byte register. Okay, so notice in here when we put $74, that's only 1 byte. Okay, so the first half will be 00. Will be 00 in this case, and the second half will be 74. Okay, and if we want to keep going further, that just going back to clear A, this was $00, and then this guy was $57. Okay, all right, and so also I forgot, D is also the addition of these two guys, right? Well, the combination of these two, well, the sum of these two guys, so which is $0057. Okay, all right. So now when we go to BSR sub, so BSR is almost like calling the routine for sub, and sub is defined by here. So similarly in programming, when we call a function, we name that function whatever we want. So in this case, let's say the function is sub, and sub is here. So sub is defined by these operations: push D, push X, and lease 2 and stack pointer. So what we do now is when we have BSR or JSR, okay, we take the origin, we add up all the bytes, and once BSR is called, we put in all the information, we put in the instruction length plus the origin. So for here, these guys here, so it's 3 plus 1 plus 2 plus 3 plus 2, so that should be 11. Okay, so 11 in hex is also to $0B. Okay, and just a quick refresher, 1 to 9 is 1 to 9, and 10 is A, 11 is B, 12 is C, 13 is D, 14 E, 15 is F. Okay, so for the first 7, we also know that the stack address, when it starts at 4000, it's a last in first out system. It has to decrement by 1 to have the top 7. So this is number 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to decrement by 1 every time we go up. So this is $3F, F, F, $3F, F, E, D, C, B, A, F, F, F. As you can see, I'm just decrementing by 1 each time, and I know it's going to be the same for each column, other than the last bit or last 4 bytes. Okay, in the hex. So that's what we have. So you're decremented by 1, so you go from F to E to D to C to A, to C to B to A. Okay, and so what we're going to do now is, since we did a BSR sub, we're going to take 3000, add up all the instruction length of the bytes, all the instruction lengths up to that point, and we're going to put it in. So we're going to take 3000 plus $0b, and that equals to 3000 B. Okay, so that's the first thing we do. Again, remember, BSR or JSR kicks everything off. This is the first thing that we're going to do, okay? So this goes in from the rightmost byte, goes in first. So 0B, and then 30. Okay? So now we're going to go into the subroutine sub, and so this is going to be the second step. So it says push D. Now remember, I said that D is the combination of A and B. And remember, we already wrote here that A is 00 because it's been cleared, and B is $57 because it was loaded in accumulator B $57. Okay, so the rightmost is 57 here. So we're going to put 57 in first. So $57. Okay, and then the left side is $00. Okay, so for the third one, X. So remember how we loaded X inside here, and we only had the rightmost 2 bits, the rightmost 2 bytes. The rightmost byte is 74 here, and then the left of that is just a placeholder 0, which is 00. So again, the right side goes in first, and the left side after that. So we're gonna go in first from here. So here's 7400, and that's essentially how you do the problem.